The sine rule can be applied to non-right angled triangles to find the value of unknown angles, just the same way that it can be used to find unknown sides. And we've seen that in a previous video. So the unknown angle, though, could be acute or obtuse. Okay, and this is probably the one thing that we really need to note with the sine rule when applied to find unknown angles. Okay, so, and I guess the reason for that is that the sine of the acute angle and the sine of the obtuse angle, those ratios are in fact identical. And let me give you an example. If you say, if you take sine of 30 degrees, that could be the angle in the triangle, the unknown angle that we just found. Sine of 30 is half. But what about 180 degrees minus 30? It's also half. And 180 degrees minus 30 is 150. Okay? So sine of 30, sine of 150 degrees gives you exactly the same ratio. Okay? So we need to be mindful of that when attempting these problems that involve the sine rule for angles. Okay? The other thing as well is that much like the sine rule for sides, okay, we need to have side angle pairs. So angle, for example, angle C refers to, or is matched up with its opposite side, little c. A matches up with A there, and B matches up with B there. Okay, again, you need to have those side angle pairs. Okay, and I guess that's one of the characteristics of the sine rule is that it works on these side angle pairs. Okay. And there is a video that has a proof of all this to see, well, why does it work? So if you're interested, then you could have a look at that. Let's have a look at some examples. Okay. So example A, find the value of theta in the following triangle. Okay, so we're going to assume here that the theta is acute, not obtuse. Okay, we will have a look later on. There is a video where we may have to consider both cases, but if you're not told whether theta is obtuse or acute, just assume it to be acute. Okay, all right, let's begin. So we have side angle pairs. Okay, so the first thing to look for is that, well, apart from the fact that it's a non-right angle triangle, we have a side angle pair. We have AB. Okay, so this side here and 16 degrees there. Okay, so there's a side angle pair. We also have another side angle pair, which is the 21, okay, and the theta. So while the theta is unknown, okay, this side angle pair is going to be basically equated with this side angle pair here, okay, and then we're going to solve for theta. So let's begin. By the sine rule, sine theta over 21, okay, so that's the side angle pair there, okay, is equal to sine of 16, so this is the known side angle pair, okay, over 10. Once you've got that, the rest is very, I would dare say quite straightforward. Just solve this now for theta. So multiply both sides by 21, so sine theta is equal to 21 multiplied by sine of 16 degrees over 10. Notice that at this point, I haven't even used the calculator yet, so I'm just setting it up first, and then the last thing I'll do is enter it all into the calculator and get a value for theta, and I'll round it right at the very end. Now, theta needs to be made the subject of the formula, okay? So in order to do that, if you want to find theta, a given sine of theta, you take the inverse sine, shift sign on your calculator, in other words, okay? So inverse sine, so that sine moves over and becomes inverse sine. Okay, 21 multiplied by sine of 16 degrees over 10. Okay, and that gets entered in as is on your calculator. So I'll just enter that in now. So shift sine, fraction 21 multiplied by sine of 16 degrees, close brackets, over 10, and close the big bracket there, and what do we get? We get 35.3688. I might just round this off to the nearest minute. Okay, so that's going to be 35 degrees and 22 minutes. Okay. Incidentally, and I just guess while I'm at it, if you wanted the obtuse angle, okay, so take that last answer away from 180. and we have 144 degrees and 38 minutes. And that's a possibility as well, okay? But I'm just going to quote the one answer here for now, the acute answer. All right, let's have a look at the next example. Find the value of angle alpha given alpha is obtuse. Okay. We solve this the same way as example A. It's a non-right angle triangle. Try and look for those side angle pairs. And we do. We have angle L here, 22 degrees, and its opposite side, 6. So that's a known side angle pair. We also have side LN, okay, which is 11, and its matching angle, or its opposing angle, is angle alpha, which we want to find. So again, let's set up the sine rule here. Again, side angle pairs implies we need to use the sine rule. Sine of alpha over 11 is equal to sine of 22 degrees over 6. All right. Let's make alpha the subject of the formula. Okay, so sine of alpha, let's move the 11 over. 11 multiplied by sine of 22 degrees over 6. Okay, we take the inverse sine of both sides, so that's that shift sign. Okay, alpha is equal to inverse sine, 11 multiplied by sine of 22 degrees over 6. Right, let's work that out. Okay, so shift sine. Okay, so that's that. Okay, fraction. Okay, 11 multiplied by sine of 22 degrees over 6. Close bracket. And again, I'll round this to the nearest minute. 43 degrees and 23 minutes. Is this the correct answer? Some of you might be saying, yep, that's good, that's correct. Some of you might be saying, no, actually, go back and read the question again. So it helps to read the question at least twice. Okay, go over it and make sure you don't miss any details. What does it say? It says, given alpha is obtuse. That's acute. Okay, so this is the acute angle. We need the obtuse angle. Okay. Okay, how do we find the obtuse angle? 180 degrees minus 43 degrees, 23 minutes, and that's equal to, I'll just put it here, 136 degrees and 37 minutes. Okay. So this angle alpha here, okay, is 136 degrees and 37 minutes. Okay. Is it a viable answer? Does it work? Well, sometimes you can get some really, fairly large obtuse angles, and you think, oh, hang on a moment, if I add it up to 22, so 136, 37. So this is a way to check to make sure that your answer is, in fact, I wouldn't say correct, but at least plausible, reasonable. Okay, so 136 degrees, 37 minutes. If I add that to 22 degrees, okay, I get 158.6 degrees. So that's less than 180 degrees. So that accounts then for angle N. But if you end up with an answer, let's just say, for argument's sake, let's say that was the other angle. Instead of being 22, it was 52. Okay, you end up with 188 degrees if you added up both of these angles. You know then that your obtuse angle, it can't work. Okay, so it's not a viable answer. Either go back and check your working out, or it's possible that that's in fact your conclusion. There's that the value of alpha, or the angle, is not possible. All right, let's have a look at another one. Here it is, back of the board. All right. Give you a moment to have a read of that. A flag is hung on the side of a building, 25 meters below the top. An observer on the ground calculates the angle of elevation to the top of the building to be 70 degrees and the distance to the flag to be 19 degrees. So this is from the observer. Calculate the angle of elevation of the flag from the observer. Okay. I was going to do a bearings example, and I thought, no, I'd like to do something a little bit different this time. So I think in the last Sine Rule video, or one of the other Sine Rule videos that I've put together, there's a bearings example. Nice to see something different. Okay, because angles of elevation and depression will most certainly do feature here. Right, let's draw a diagram first thing. Right, so if you're thinking, what's my first step? Your first step should be drawing a diagram. So, okay, right, there's the ground. Hopefully it's a flat ground. Here's a building. Okay, here's an observer. Right, you can see the extent of my artistic abilities here. Hopefully, as long as as long as you can see what you're doing here and it's fairly clear, you don't have to draw this, super neat. As long as it's a good clean sketch. So we know that there's a flag. Okay, so here's our flag. Right, hanging on the side of the building there. Okay, it's 25 meters from the top. Okay, so there's the top of the building. Okay, so we know that there's 25 meters there. And it's not to scale, by the way. Far from being to scale, in fact. Okay. We also have the angle of elevation from the observer to the top of the building to be 70 degrees. In fact, I'll use a ruler for this one. Hopefully I don't smudge the ink. It's always the problem with this whiteboard ink. It smudges very easily. Okay, so we know that that is 70 degrees. And we also know that the distance from the observer to the flag is 19 meters. And that's 19 meters there. Okay. And we want to find the angle of elevation of the flag from the observer. So what we're looking for is we're looking for this angle here. Okay, call that theta there. Okay. Right. Okay. So how would we go about something like this? By the way, assuming that everything done correctly, the building is 90 degrees with the ground as well. Okay. So we have a few things going on here. Okay, we have a right angle triangle. Okay, you've got 70 degrees, you've got the hypotenuse of 19. So we could in fact find this side here. We can find how far the observer is away from the building. Is that going to be of any value to us? Well, we don't know. We do know that it's 70 degrees from the ground to the top of the building. Okay, that's the angle of elevation. So if anything, if we can find this angle here, okay, so let's call this angle alpha, subtract it from 70, we've then found our angle theta. Okay, so I might just make a point of this, that angle theta is really equal to 70 degrees minus angle alpha. Okay, so I just wanted to make sure I get that. But we need angle alpha. How would we work that out? Okay, we're going to have to use the sine rule here at some point. Problem is we don't have any angles inside this triangle. Okay, so what could we do in this case? Now, something else well worth noting is look at this large triangle here. Okay. In fact, I might just use it. So this angle there, so this angle here in green, okay, just to make it a little bit clearer. Okay, that's 70 degrees. Okay. So See this right angle triangle here in green? This angle here is 70. If we can get an angle up here, then I think we've got enough information then to use the sine rule, because we'll have a side angle pair. Okay, so let's call this angle beta. Okay, I've used quite a few Greek letters there. Okay, so angle beta is equal to 180 degrees minus 90 degrees. So this is on the green right angle triangle. So it's actually triangles superimposed upon each other, isn't it? All right, 180 degrees, okay, minus 90 minus 70, and we get 20 degrees, okay? So there's our angle beta. Okay. Now what I'm going to do, just to make it a little bit clearer, is I'm going to redraw the non-right angle triangle part. Okay. So I'll just do that a little bit. Here we go. That's 25 meters. This is 19 meters. We have now found this angle here. Okay, this angle here is 20. No, 20 degrees. Okay, we can now use the sine rule to find our angle alpha. Okay, so let's do that. Sine of alpha, okay, over 25 meters, that's the side angle pair we're dealing with here, is equal to sine of 20 degrees, that's the angle here at the top that we just found, over 19. Okay, so that's this side angle pair here, and that's that side angle pair there. So this side angle pair and that side angle pair. Okay. So alpha, okay, sine of alpha, I'm going to have to do the rest of the solution on another board. Sine of alpha, if you multiply both sides by 25, multiplied by sine of 20 over 19. Okay, I'm just going to use another board here. Okay, so alpha is equal to inverse sine. Okay, so we just want alpha on its own, making it the subject of the formula. 25 multiplied by sine of 20 degrees over 19. Okay. Let's find this alpha. So, yep, let's find this alpha. So, shift sine. Okay, fraction 25 multiplied by sine of 20. Yep, over 19. And we get 26.74. So again, let's round this to the nearest minute. Okay, so that's going to be 26 degrees 45 minutes. Okay, so now we want the angle of elevation of the flag from the observer. Okay, and we need to use what we discovered early on, that the angle theta, which is the angle of elevation that we want, is 70 degrees minus this angle alpha there, okay, to give us then our angle theta. Okay, so angle of elevation okay, 70 degrees minus 26 degrees 45 minutes, okay, and that would be 43 and 15 minutes. Okay, there you go, and that's it. So I might just put the answer here. So that angle of elevation is 43 degrees and 15 minutes.